It is actually quite useful to know symmetry of graphs. I'm going to go through this quite quickly. Symmetry about the y-axis. Okay lah. When we study this, actually you think of classical example. Y equals x squared is a classic case of symmetry about the y-axis because like that, right? What is the property? The property is just for any point, say 2, 4, you have a point negative 2, 4. Am I right? So for a point A, B, you also have a point negative A with the same y coordinate B. Which means this for the same, for one x coordinate, substitute A and you get one B. If you sub negative A, you will also get B. If that property is satisfied by a curve, then that curve must be symmetrical about the y-axis. Look here, of course. Alright? We square a value and 2 squared is the same as negative 2 squared. 8 squared is the same as negative 8 squared. So this property is satisfied. Alright? If the equation remains unchanged when x is replaced by negative x, then it is symmetrical about the y-axis. So similarly, oh sorry, not yet. Example. Example. Yeah. Oh yeah, example. Example 8. Let's look here. If x is replaced by negative x, what happens? You have negative x squared over negative x4 plus 1. Of course, you will get back the same thing. Correct? So it tells us that then y-axis is a line of symmetry. Okay? Good? Easy? Yeah. Symmetry about the x-axis. I think if you understand symmetry about y-axis, you should understand symmetry about x-axis. Never mind, let us still use the classic example. Okay. Y squared equals to x. You have 2, you have 4, 2, and then you have 4, negative 2. Correct? Have attention. How do we tell that a graph is symmetrical about the x-axis? For a point A, B here, you must have a point A, negative B. Have attention, please. Why is there so much talking? Are you okay? Okay, look. Okay, that means for the same x coordinate, okay, you have b and you have negative b, you will have the same x coordinate. Okay, for different y coordinates, y is b, y is negative b, you will share the same x coordinate. So, you look here, you will know what I mean. X equals to 4, you get y equals to 2 and minus 2. So how do we tell? If I replace, look here, if I replace y, which is 2, with negative 2, I will still get back the same x. Am I right? So that is how we tell whether a graph is symmetrical about x-axis. When the equation remains unchanged, when I replace y with negative y, I'll still get back the same x. Then it is symmetrical about the x-axis. Okay, I'm going to go through this very quickly. First one, here. Okay lah, quite obvious, right? Quite obvious, right? The part one. Replace x with negative x, you get the same thing. So therefore, the y-axis is a line of symmetry. Okay, I replace x with negative x, I will get the same y, so y-axis is the axis of symmetry, line of symmetry. If I replace y with negative y, I will still get back the same thing. Therefore, the x-axis is a line of symmetry. Then let us use this to find out what about this. This is still okay. I replace the x1 is complicated. Am I right? I cannot just say I replace x with negative x, I get the same equation. No, I don't. But y fine, okay, not too bad. I can replace y with negative y, I will still get back the same equation. Therefore, x-axis is a line of symmetry. Okay, now we have to use a bit of prior knowledge. Let's see. Let's assess how well you understand chapter 9. Okay, how good is your chapter 9 lecturer? Who? What is chapter 9? Very good. Excellent. Good question. Later. This is S what? Okay. Look. Can you have attention? This graph, can you have attention? This graph was symmetrical about the y-axis and x-axis. So, I'm going to use the red line. The axis of symmetry is this and this. Correct? Like that. So, no matter how the graph looks like, it's symmetrical about x-axis and y-axis. X-axis and y-axis. No matter how it looks like, it can be a circle, whatever, I don't know. Okay, it is a circle. No, it's not. Okay. Anyway, from here to here, what is the transformation involved from here to here? What's the transformation involved? Transformation, describe geometrically, what is the transformation? From here to here. Okay, don't need so long. It is when you replace x with x minus 2, it is a translation 2 units in the positive x direction. Okay, can I have attention? Look up, look up, look up. So which means no matter how the graph looks like, the whole graph will be translated in the positive x direction by 2 units. So while the x-axis still remains as an axis of symmetry, line of symmetry, then this line of symmetry is now not the y-axis, but it's actually the line x equals to 2. Very good. Okay, this one I just said.